For the first part of part C, it helps to look back at our code for sort edges by weight, okay? So we're given that the sort method, the ArrayList sort method, is going to run in, it's going to be upper bounded by O of n log n and lower bounded by n, where n is the number of items being sorted. We know that n is equal to e, the number of edges in our graph, right? So we know that the sort is going to be upper bounded by e log e and lower bounded by e. So if you look at this method, right, that's going to come into consideration here at this step. But what about this for loop? Well, the for loop is really just going through the adjacency matrix dot length, right, twice. And so, or I guess squared, right? So remember the adjacency matrix has dimension v by v, right? And so if we're going through almost all the cells here, that's v squared. And so runtime for part I is going to be, yeah, let me write it here. It's going to be O of v squared. This is for the iteration through our adjacency matrix, plus, okay, e log e, and this is the upper bound. And the reason it's upper bound is because we have upper bound and lower bound for the sort method, right? So in the worst case, where our log n is going to be upper bounded by the e log e, this is going to take total of O of v squared plus e log e time. And then in the case where it's lower bounded by n, right, that's going to be lower bound of v squared plus e, okay, where e is equal to n.